In this video, we're going to go through a problem that uses the fundamental theorem of calculus version 1. So just to state it, just in really quick terms here, all of the functions that we're going to deal with happen to be continuous functions. So in a really quick form, if you have the function g of x, so a function g whose input is x, defined as integral from a fixed number a all the way up to x of some function f which has input t, and you're doing this integration with respect to t. So when you have something like this, fundamental theorem 1 says that you can actually get out of this, that you can get that g prime of x is equal to f of x. Okay. The thing that we're going to do in the upcoming problem is to do this where the function g has not input x but has input u, but it's all the same, so just replace all of the x's which appear here with a u. Let's just do that right away because I think that'll make things a little bit easier to look at. So either way you do this here, you can write g prime of u, or you could, instead of writing it like that, if you want to really specify, you could write dg du, and that's going to be equal to f of u. So I just wrote the two different notations for derivative right there because of what's coming up. The example I want to look at right now is, let's take the derivative with respect to x of this. So here's a function of x, okay, and this function is going to be integral log base 4 of x, and the upper integral, the upper endpoint of the integral is 5 to the x, and the integrand here is going to be sine of t dt. Alright, so when you see something like this, so the thing is, we have a function both up there and down there, so on both endpoints of integration. So the first thing to do is to split this up. You pick a number, any number you want, and first use this property of integration, so log base 4 of x, and you pick a number. Let's just let's pick a 10, for instance, right? Then you have sine t dt. Okay, so then, I mean, the point is that the area of sine of t from log 4 to 5 to the x is the same as the area from log 4 all the way up to 10, plus the area starting at the t value of 10 and then continue on up to 5 to the x, sine of t dt. Alright. And then the thing is that the way fundamental theorem works is you need the fixed number to be down at the bottom there. So that's good right here with this 10. That's not so good with this log base 4 of x. So we're going to swap these two, but that's going to introduce a minus sign. So I should note that these two things are equal, and what we're about to write is going to be equal. So first, this derivative sign, we're not taking the derivative yet. Now swap these two, but that introduces a minus sign here. So you have negative integral from 10 to log base 4 of x of sine of t dt, plus this one stays the same, integral from 10 to 5 to the x of sine of t dt. Okay, to differentiate these two things, you can split at the plus sign. So here's the sum rule for differentiation. So this will be the derivative of, and let's just take that minus sign out in front even here, right? So using the constant multiple rule, the derivative, so negative the derivative of integral 10 to log base 4 of x sine of t dt, okay, plus still this derivative, we have to differentiate the second term as well, the derivative of integral 10 to 5 to the x of sine of t dt. Okay, so now what we have are two smaller problems where we still need to use a fundamental theorem of calculus combined with a chain rule. So this function here, okay, this is the function g, and right now it's really a function g with input x, and you can write g of x if you want, but what I'd like to do right now is replace this log base 4 of x with a u. Okay, so if you write u is equal to log base 4 of x, well, the thing is, right here, ignoring the minus sign, right, what else is here? So let's think of this as work off to the side, okay. But here this says derivative of g with respect to x. Okay, that's what this is right here, really. And this, by the chain rule, is going to be the derivative of g with respect to u times the derivative of u with respect to x. Okay. So what do we have here? Well, this equals, copy that minus sign. And right here, this is dg dx. That's right there. So we're going to replace it with dg du. Okay, well, what is dg du? Well, let's write down g as a function of u first. Okay, g as a function of u. Just replace here. Here's g, but this is an integral 10. This log base 4 of x, that's what we called right here. That's what we called u. So replace this log base 4 of x with a u here. And you have sine of t dt. Okay, and here this just, where were we? We're looking at this thing, this dg du. U looks like this, and so this fits the setup of this fundamental theorem, this version with the u's written. So then we're looking at g prime of u, the derivative, or dg du more specifically, and that's f of u. And f of t is sine of t, so f of u is sine of u. Alright, so that, in parentheses there, is the dg du. We have to multiply by du dx, so take this. If u is log base 4 of x, then du dx is going to be 1 over x ln 4. Alright, let's kind of continue the same sort of work here. So we'll do all the same steps and copy that plus sign. Here, same idea. This right there, what's in the square brackets, let's call that h so that we don't end up using g again. And I'd like to call this 5 to the x u, except u was u, so for v, we'll call v 5 to the x. Same thing, we're going to use the chain rule, so just to write down what that was here, what we're going to need is, well, you see here it's dh dx, dh dx. Okay, and the chain rule says that this is going to be dh dv times dv dx. Okay, since we've written h this way, so if you want, I have a little more room than over on this side, so let me do a little bit more explaining. If you think of h as a function of x, okay, then it's just literally writing down what's in the square brackets there. So this is integral 10 5 to the x sine of t dt. But then if you think of h as a function of v instead, so combine those, then you have h of v. Okay, this notation is maybe a little weird here, but I'm thinking of h as a function of v. Integral 10 all the way up to 5 to the x. Oops, that's a v though. Okay, of sine of t dt. Now read this entire line, fundamental theorem again. Actually, I have room. Let me write it down. So replace all the g's with h's, replace all the v's, the u's with v's, and so you have h of v equals integral from a fixed number all the way up to v of f of t dt. Okay, and this is going to be dh dv is equal to f of v, and we're about to use that right here, right? Because what we have here is dh dx. So dh dx we're going to replace with dh dv, which is going to be f of v, and f of t is sine of t, so f of v is sine of v, times dv dx, and then so right here there's v of x, and we need the derivative, so this derivative will be 5 to the x ln 5. Okay, almost done. The last thing we need to do is, if you look back at the example, there's x's and t's, but here in our answer so far we have a u and a v, so let's replace those. So there's that minus sign to copy. Sine u is log base 4 of x, and this is all times 1 over x ln 4. Okay, copy that plus sign there. Then you have sine of, and v, where's that? That's right there, that's 5 to the x. And this is multiplied by 5 to the x ln 5.